Now for carbon dioxide, here the central atom, the least electronegative atom, is going to be the carbon because it's further to the left and down on the periodic table from oxygen. And so when we consider the number of valence electrons, carbon has 4 valence electrons and each oxygen has 6 valence electrons. And so the total number of valence electrons is equal to 4 for the carbon plus 2 times 6 for each of the oxygen. And so that comes out to be 16 valence electrons. Now, for number of bonds, we have a total of 3 atoms. So this is going to be 8 times 3 minus the number of valence electrons. And the number of valence electrons we have here is 16 divided by 2. So 24 minus 16 is 8, and 8 divided by 2 is 4. So we're going to have 4 bonds here. And so remember that carbon is our central atom, and we're going to draw 1 bond to each of the oxygen. But we still have to add 2 more bonds. And so now we add 1 more bond between the carbon and each oxygen. So now we have a total of 4 bonds here. We have a double covalent bond between the carbon and each of the oxygens. Now, if we consider the carbon, it has each covalent bond accounts for 2 shared electrons. This is 2 electrons, 4, 6, and 8. So the octet rule is satisfied for the carbon. And for each oxygen then, we have 4 electrons accounted for. So now we have to add electrons to satisfy the octet rule. And so now we've got a total of, if we count up the electrons, 2, 4, 6, 8, 10, 12, 14, 16 valence electrons. And that's what we've figured out we should have had from part 2. So this is the structure of carbon dioxide. So this is really should be double bonded here, but this is just to show you what the shape of the molecule is. Remember that there are no lone pairs around the central atom here, the carbon. And so these oxygen atoms are going to get as far away from each other as they possibly can, which is at opposite ends of the carbon atom, the central atom. So the shape of this molecule is linear because there are no lone pairs. And so this is different than the case of the bent molecules such as carbon difluoride and water, where there are lone pairs of electrons around the central atom which push the 2 bonded atoms closer together. So the bond angle here is actually 180 degrees because this is the furthest apart that these 2 oxygen atoms can get from one another.